Today is the first way that we're going to look at multiple representations of linear equations. There are different ways to represent mathematics, so the learning target is you can go from words to tables to graphs to equations in any order. So let's start with the first problem. Jacob wants to get a video rental account. The rental store charges a $10 per month charge no matter how many video games are rented. They also charge $2 per video game rental. So our goal is to fill out this whole sheet right here, table, graph, equation, and then kind of relate the three. So let's start with the table. So right here, let's start with our independent, dependent variables. So independent variable here would be time, and the dependent variable would be would be actually the cost. So two variables are things that are changing, and so the time, the number of months, is independent. The cost is going to depend on how many video rentals per month. So let's actually change this. It's not time. It would be number of rentals. Okay, so the two things that are changing are number of rentals, and that affects the cost. And in a table, our independent variable goes first, and our dependent variable goes second. So let's move this up. And again, here we're going to say that X is number of rentals for any month, and Y will be the cost. So let's start with 0. If Jacob rents 0 videos, the store charges $10 per month no matter what. For one rental, it's an additional $2. So we have our $10 plus an additional $2, that would be $12. For 2 rentals, it would be an extra $4 to our $10 a month, so this would be $14. For 3 rentals, let's go all the way up. So for 3, we have 3 times 2 is 6. 6 plus 10 is 16. And then we'd have 18, 20. You can see that these are all going up by 2. Okay, so we went from words to a table starting at 0. We had our initial cost, it's like the y-intercept, and then we knew it went up $2 per every rental. So now let's graph it and actually go back to the equation here. So again, if we go to the equation, we have y equals our starting value. Well, that was at time 0, the y-intercept is 10, and it's going up $2 for every rental. So here's our equation. The independent variable is x, which is number of rentals, and the dependent variable is y, which is going to be your cost. And let's graph. So the first point we're going to graph is 0, 10. So at 0 we have 10 rentals. At one rental at 0 it's $10. At one rental it's $12. At 2 rentals it's 14. And the slope is going up by 2 every time. So at 3 it's 16, and so on. So here is our line. Okay, so this is what we want to be able to accomplish today. Can you go from the words to the table to the graph to the equation from any order? So let's try another one. Okay, so this one starts with the table. So the first one was the words. We got everything. Now the table, we're going to get everything. So our table, I'm going to start, it looks like this is going up by 2. So if I go backwards, this is 0. And this is 12, so this would be 14. Let's find the pattern. It looks like it's going up by 4 every time. So this would be 15. This would be 19 and 23. And let's define our variables. So we have our x and our y. We have to come up with a situation here. So let's say this is the amount of money in your bank account. So let's say you start by owing the bank $1. You add $4 to your account each day. Okay, so if this was the case, then x would be the number of days, and y would be the amount in your account. And our independent variable again would be number of days. Dependent would be amount in the account. And the equation would be y equals our starting value at time 0 is -1. Our slope is increasing $4 per day. Let's graph this. So at 0 it's -1. At 2 it's at 3. At 4 it's at $7 in the account. At 6 it's $11 in the account. At 8 it's $15 in the account. At 10 it is $19 in the account. All right, so it makes a straight line right here. All right, so this time we went from the table to all of the different models. We have 2 left. Let's go from the graph to everything else. So the graph, it starts at 6 and it goes down 1. So I'm going to say at time 0, that starts at 6. At 1, it's now at 5. At 2, it's at 4. 3, it's at 2. 2, it's at 1. Oops, I'm going down, sorry. All right, so at 2, it's 4. At 3, it's 3. At 4, it's 2. At 5, it's 1. And at 6, it's at 0. Let's make up a situation. So let's say Miss Bayesian has 6 pencils. And she loses 1 per day. All right, so in that case, X would be the number of pencils. Actually, no, X would be the number of days. And Y would be the number of pencils. Okay, so again here, X and Y, number of days, pencils, number of pencils. Let's write the equation. So the y-intercept starting value, I start with 6 pencils, and I lose 1 pencil per day. So I can write 6 minus x, or 6 minus 1x. All right, we've got one situation left here. So this one, we start with the equation. So the equation is y equals 5x plus 6. So if I make my table, the starting value is the y-intercept at 6, and the slope is 5, which means it goes up 5 per day. So we got 11, we got 16. That's not very nice. 16, 21, we have 26, we have 31, and we have 36. And let's pick our variables and make a situation here. So let's say you start with $6 in your account. And you gain $5 a month, we'll say. All right, so X will be time, number of months. And Y will be the amount in your account. Here's our equation. Let's graph. So at 0, we got 6. At 1, it's 11. At 2, we're all the way up to 16. At 3, it's up to 21, and that's all we can fit on this graph. All right, so we've practiced looking at equations, words, tables, graphs, and this is what we're going to spend the next 3 days on in class.